What's up guys, Daniel here. In today's video I'm going to be showing you how you can create a sway system in Godot or item retraction system in Godot. So what is the problem that we're trying to solve? As you can see here in the demo, I have in the hand of the player a little broom, and the problem is that when I move close to a wall it clips through the wall. So as you can see it just doesn't look right. And what I'll be showing you today, let me just enable this little system, is how you can make something like this. When you go close to the wall, instead of the item retracting, it will move away from the wall. So as you can see, this is pretty cool. If I close the door, as you can see, it doesn't clip through the door. And when I open it, it like smoothly goes towards it. So let's see, as you can see, it also works here. Let's see how you can make something like this. And as you can see, it's not perfect because sometimes it does clip through the wall, so I also have to fine-tune this system, but it's good enough. So let's see how can you make something like this also in your game. This is a very common issue because in a lot of the games you want to have something in the player's hand, but you also probably have walls. And if the player goes towards the walls, you don't want the item to clip through the wall. It doesn't look that nice. So let's see how you can achieve something like this. And if you're interested, this is for a game I'm making called The Final Shift. It's out on Steam, you can wishlist it. It's a horror game where you play as a janitor in a building that has some kind of, well, let's say, messed up history or disturbing history, and it unfolds as you play the game, and there's also a plot twist at the end and some secret endings. So you can check it out if you want to. It will be in the description. I would highly appreciate a wish list. So let's go on. Let's actually look at the code. Let's not waste your time. Let's look at how this is implemented. So I have my little broom scene here with the broom. And it's all happening within this script. So let me just explain to you quickly in Paint, of course, because, you know, a good tutorial has to have some kind of paint, you know. So let's look at how this works. So we have the player here, and we have a wall. And the player is holding some kind of item. And what we want is, as the player approaches, we want this item to retract. And how we achieve this is that we cast a ray from the player's camera. And we check how far away the player is from the wall. And if the player is close enough, we move this item back, we retract it by some kind of amount, by some kind of distance. So for example, if the player, well, let me just redraw everything. So if the player were to be right in front of the wall, we would want this little item so instead of being like this, we want it to be like this, or something like that, you know, so it doesn't collide with the wall, it doesn't clip through it. And again, let me just say it again, the way we do this is that that was a very ugly player, but anyway, the way we do this is we cast a ray towards the wall, we check the distance towards the wall. If this distance is less than some kind of threshold, we calculate about how far away is it from the player, and we move back the item by some distance. So let's see how this is implemented in code. First of all, we have some kind of variables. So the length of the ray that we cast, how far away we want to check the wall. But let me just go to the code. I check this in the process function. This process function gets called every frame. And what we do here is, first of all, we need to create that ray that goes towards the wall. So we get the space state. To be honest, I'm not sure what this is. I just know that we need it for the ray casting. We set the first position. So the ray needs 2 positions. Let me just show you. So the ray needs 2 positions. It needs to know where it needs to start from. That will be the player's head, and where it needs to go towards. So we need 2 positions to create a ray. So the first position will be the camera's position. So I just have a variable here, the camera. I set it here in the ready function, I think. Or not. Oh, I check it here. So if I haven't set the camera's position yet, then I just get it from a global script. But somehow you need to get the player's head. You also could do this in the player script. So for me, this is not inside the player script, this is inside the broom script. But you need to get the player's position. I recommend getting the head position, so or maybe the torso position, because it just gives you a more accurate array. Because otherwise, for example, if you get the feet position right here, the ray would look something like this, or even something like this, and that's kind of awkward. I mean, it's much more. I think it's better, or it looks better at least, and it probably acts better if you either cast it from here or cast it from the head. So you get that position, and then we need to get the other position, the other point, where we want to go to. So we get the front and we get the 2. And the way we get the other position is by adding a little bit amount to the player's head. So let me just show you yet again in Paint. So we have our player over here. We have this position, and we just add some distance to that position, some distance, and we have our other point. And now we have our ray. So the ray will be this line. We can set, by changing the distance, we can also change the distance of the ray. So we get our player's head position, and we add to it some kind of distance. Now what is this distance? First of all, I have this wall check distance. This is just set to 2. So from 2, let's say 2 meters from the player, or 2 units from the player. And then we get something like this, camera.globaltransform.basis.z. So what this basically is that we are in 3D space. So we have 3 axes. This is the z-axis, this is the y-axis, and this would be like the x-axis. And in Godot, the forward position, so basically ahead, what is ahead of the player is the negative z-axis. So this would be negative z-axis, this would be the positive z-axis. So we need to step forward in the positive z-axis. And this is what we're doing here. We get the z-axis, the negative, as you can see, the negative z-axis of the camera, and we multiply it by this distance check. So this basically ensures that we are looking ahead of the player, not behind or to the left or something like this. Then we create this physics ray query. We pass the 2 parameters. Then we do something like this to exclude the self, because how this works is that we have our player over here. This is our player, and this player might have some kind of collision, and when we cast a ray, what it does, it checks for collisions, and if it also checks for the player's collisions, it might just get stuck right there every time. So we might just read that, okay, the ray is colliding, but it's not colliding with the wall, it's colliding with the player's collision. So we want to exclude this collision, and this is how we do it. We set the exclude to self, sorry, this doesn't check for the player's collision, it checks for the broom's collision. So that is what it's checking for. But this is important to keep here. We also set a collision mass, so what should it collide with? I set the collision mass to be 1, so that for me, the collidable objects like or I mean like walls or things like that is set to the 1 collision mass. So I just set it to, okay, just collide with the walls, ignore the player and everything else. Then we call this intersect rate function. This will return to us either null if it didn't collide with anything, or the object with which it collided with if it collided with anything. So we check if we have a result, if the ray collided with anything at all. We find out how far away is that object. So we get the from where we cast the ray, the distance to the result. So how far away is that object? Then we see, okay, is this distance within our boundary check distance? So this boundary check distance, we have our player, and for example, this distance for me is 2. So if the wall is right over here, this if statement won't be true. But if it's within this range, this distance will be less than 2, so the if statement, so this will be true. So if we're close enough to the wall, we calculate a ratio. So we think, okay, about how close we are to the wall, so that we know how far we need to retract our object. And let me just show you, I asked AI, it created a really nice like little formula here. So as you can see here, this push ratio is given by this formula. So 1 minus the ratio of how far away the object is divided by how far away we're looking at. So for example, if the wall is really far away, then this distance will be pretty high. So it will be a high number, for example 2 divided by 2, which is 1, and then 1 minus 1 will be 0. So we don't have to move the map at all. Then if, for example, if we're right up against the wall, this distance will be very close to 0. So if we divide, for example, 0 by some kind of number, we get or a number close to 0 by another number, we get a number that is close to 0. So this 0 divided by 2 will be 0, and 1 minus 0 is 1. So we need to retract the item completely. And everything between gets us a nice value. So it gets us this is like a smoothing factor. So how far away should we move that object? 1 would be move it completely, 0 would be do not move it, and anything between would be like, okay, move it a little bit. So for example, move it about 75%. So this is what this does. And then we clamp it to be between 0 and 1, so we don't get any weird transitions or weird values. What did I want to show you? I want to show you, oh yeah, so then we set the target position. So where should we retract to? Where should that item go to? Where should it retract to? First of all, we take our current position. Then I have this retraction offset and I multiply it by this push ratio. Okay, sorry guys for that audio break there. My audio device, my microphone just died. It ran out of battery. So I'm back. I gotta check my, OBS that okay, right now the audio is good because it just died, and my other microphone is pretty bad. But where I think I left off is explaining this. So we calculated the ratio, how much we want to move the object. Now we have something like this. So we calculate the target position. So where should we move that object? We take its original position and when we apply an offset. And the way we do that is I have over here this, okay, mic is still working. I have over here this retraction offset and I multiply it by the push ratio. So how much should we push it? What this retraction offset is, this is basically just a vector. So a position for where should we move this. And you can think about it like this. Let me just go back. So, for example, we might have our player over here from the top view, and we might have our object over here. And, for example, if we have a wall over here, we want to move this back. Okay, but where do we move this back? We need some kind of anchor point, some position. So we move it back, for example, over here. And this is the point where we move it back, and this ratio tells us how much we pull that back. So how much we want to pull it backwards. And then we calculate that position, and then we just move towards that position. We move the item towards that position. And how we do that is we get the position of your item, for me it's the mob, and I just lerp it or linearly interpolate it towards that target position. And this basically just ensures that the mob will move in a smooth way, it won't lag around or something like that. And when you do that, you take delta and multiply it by some kind of speed. For me this is 10. Now what this delta is, if you don't know, since this is running in the process function, and the process function runs every frame, but there might be some delays between frames. So this tells you the time that has passed between this frame and the last frame. And this basically ensures that whether the player is running at 60 FPS or 300 FPS, the animation or the retraction won't depend on how fast the player's computer is. Because if, for example, the player was running at 20 FPS, this would only get called 20 times per second. If it were going 400 FPS, it would get called 400 times per second. So it will go, at the 400 FPS, it will go back a lot faster than in the 20 FPS version. So, but by using this delta, we can regulate it. So we multiply by delta, so it doesn't depend on the player's frame rate. So yeah, that's about it. So this is how you move an object, get this nice little effect. If you have any questions, please feel free to leave a comment. Oh, I forgot to explain this. This offset is basically this. This is what it means. So move this much in the x-axis, so slightly left, lower it down a bit, pull it back towards the player, and that is basically the position that we get. So yet again, if you're interested about the game I'm making, it's out on Steam. It's called The Final Shift. I like it. I think it turned out pretty well. The gameplay is about 30 to 40 minutes, about that much. So you can wishlist it if you want to. Leave a comment, like, subscribe, all of that stuff. And I'll see you in the next tutorial. Goodbye.